Alright, so we're up to 6.6. Again, this is a new thing we're doing today. That doesn't rely completely on what we've done the last couple of days. Okay, so another new thing. Right, so on page 49 of your notes. Right, so if you've got your notes, underneath the heading, Trig Identity. Mira, Robin. So underneath the heading, Trig Identities, the may need to be considered when solving equations on trig. Can you cross that out, please? Because that was for the previous section. I've obviously copied paste and didn't delete that section. So, in your notes is a summary so far of what we've done so far. Okay, so we had a look at the reciprocal ratio, so on page 49. Okay, I really need you guys to bring in notes if you haven't got your notes there. I'm not going to write it all up again when it's there right there in front of you. So we have the three reciprocal ratios. We've got cosec of theta, we've got sec of theta, and cot of theta. Okay, so you need to know what the reciprocal ratios are. Okay, so we take the third letter of each of those letters and it'll tell you which one you need. We also looked at complementary angles. So we looked at sine of theta, which is equal to cos of 90 take away theta. We had cosec theta, which is equal to sec of 90 take away theta. And we have tan of theta, which is equal to cot of 90 take away theta. And we've done that proof earlier on in the topic. Right, the last couple of lessons, we were looking at angles of any magnitude. So basically, before I do trig identity, so quick summary of last couple of lessons. So we're considering our quadrant. We have gone through the proof early last week where either sine, cos or tan is positive in those following quadrant. So in the first quadrant, all of the three ratios are positive. So in other words, to take an angle between 0 and 90 for sine, cos and tan, you'll get back a positive result. In the second quadrant, only sine is positive, so you take an angle between 90 and 180 degrees. Alright, if you do that for cos and tan, you're going to get a negative value. Alright, so similar with tan and cos for the angles in the respective quadrant. Alright, only tan is positive in the third quadrant, and cos is the only thing that's positive in the fourth quadrant. Okay, everything else is negative. And that was part of the work when we had to look at angles of any magnitude. Okay, so for example, we had sine of 300 degrees. All right, we need to get an exact value for that, and that's in the videos from last week. All right, and then we looked at equations, also following up from finding exact values, we'd incorporate those into equations. So if you've been away, you really need to prioritise that work, viewing that video, or coming and see me as soon as possible so that you can get the work done. Right, so we're going to consider the diagram below. So you've got the summary in that table, what everything we've done so far. So back in the angles of any magnitude section, we saw that sine of theta was y, cos of theta was x. Okay, so way back when we started the four quadrants in terms of where the angles are positive. Alright, so we had a number plane. We had a unit circle, probably one of my poorer attempts at drawing a circle recently, with radius 1. We had the point on that circle x, y. Okay, we use that point around our four quadrant, changing the signs of x and y for the respective quadrant. Alright, we finished the right angle and we had value x and value y for the distance to the right angle. Okay, so we had the angle marked theta inside that diagram there. Okay, this was all when we did the work last week. We are continuing on that work. So we had the following result. Sine of theta, which is y, so opposite from angle theta is y, over the hypotenuse 1. So from that diagram we have sine of theta equals y. And similarly we had cos of theta, which equals adjacent over hypotenuse, and the adjacent side is x over the hypotenuse radius 1. So we have x for that. And the ratio of tan of theta, alright, which equals the opposite over the adjacent. Alright, so with respect to theta, the opposite is y and the adjacent is x. So y over x is that ratio from that diagram. Okay, which equals sine of theta over cos of theta. Sine of theta is y, cos of theta is x, so replace x and y in that fraction, and we have our first identity. Tan of theta is equal to sine of theta over cos of theta. Okay, now cot of theta. Okay, so again you can either flip this value over, okay, or it's 1 over the value of tan of theta, or in other words we just need to flip these two values. Remember, for your reciprocal, your third letter tells you sine, cos or tan, goes on the bottom of the fraction. Okay, so it's 1 over tan of theta. Right, so going back to the original fraction is equal to x over y, so we flip that fraction over, and therefore cot of theta is going to be cos of theta over sine of theta. And that is your second identity. Right, does anyone here know the equation for a circle? Radius 1, centre point 0, 0. Anyone know in general what the equation of a circle is?
It's like the something equals something squared plus something squared.
Yes.
Yes.
Yes?
Yeah.
What's the somethings?
Z equals x squared plus y squared.
Alright, circle has equation, right, x squared plus y squared, which equals to the radius squared. Right, this will be covered up in when we do functions and graphs, but we're doing trig first so that the extension trig has done all their trig, mathematics trig, before they go into extension, and this is one of the reasons why what we're doing today. Alright, that's for a general circle that you would have hopefully you've learnt last year. At all? No? We'll cover it when we do functions and graphs. Alright, so our unit circle back here. So unit circle means the distance is 1. Okay, so in other words the radius is 1. So up here we have, for our unit circle, we have x squared plus y squared, which is the radius squared, which is 1. And what was x and y from the previous page, my previous page? Good, okay, so that means cos squared theta plus sine squared theta is equal to 1. Now you may have remembered one of our previous examples. We had a particular angle, we did cos squared of that angle, sine squared of that angle, we add them together and the result was 1. Okay, there's your proof. Alright, so taking the numbers on the variables on the number plane for your radius as well, and that is now your third identity. Alright, so in other words, sine squared theta plus cos squared of theta is equal to 1. That is your third identity. Okay, you don't need to remember how to derive them, but you need to know the results. Extension students, I suggest you pay more attention to how it's derived because that will help you with your extension trick. Right, so that's now equation 1, which is really identity 3. Right, so from that we can get another 2 equations, okay, another 2 identities. So if I take that equation and I'm going to divide everything by sine squared of theta. Before I do that, just a memory note, so sine squared theta mean sine of theta or squared. Okay, that's what you would put into your calculator if you need to do that, like sine squared of this particular angle, but when it's notated in a question or in our note, okay, we notate it with the square after the sine, cos or tan and before the value of the angle. Okay, but you need to know that's what it means. Alright, so let's divide that equation by sine squared of theta. So we have sine squared of theta over sine squared of theta plus cos squared of theta over sine squared theta, which is 1 over sine squared theta. So everything is getting divided by sine squared of theta from equation 1. So now we're really the last 3 or 4 lessons is moving on to new stuff. Alright, so what is sine squared of theta divided by sine squared of theta? 1. Okay, they'll cancel to get 1. Now, what is an expression for cos squared of theta divided by sine squared of theta? Cot squared of theta. So we go back to my previous page. Cot theta is equal to cos theta over sine theta. Okay, that was our second identity. So cos squared of theta over sine squared of theta will become cot squared of theta. Right, 1 over sine squared of theta. How do I write? What's another way, sorry? I can write 1 over sine squared of theta. Well, what is 1 over sine theta? What's an expression I can write for that? Cosec. Okay, so the third letter gives the reciprocal. Alright, so therefore 1 over sine squared of theta is going to equal cosec squared theta. That is your 4th identity. The 1 in the cot is cosy. And that's how you're going to remember it.
That was really late.
The 1 in the cot is cosy.
That's so lame, but like...
Yeah.
Alright, so as well as dividing equation 1 by sine squared of theta, we can also divide equation 1 by cos squared of theta to get our 5th and final identity for this section. Alright, so sine squared theta over cos squared theta plus cos squared theta over cos squared theta. Now we usually go sine then cos. When you do sine squared plus cos squared is 1. That's typically how it's done. Although up the top when I derived it, it's in the other order. Doesn't matter. Equals 1 over cos squared theta. Okay, so everything in equation 1, sine squared plus cos squared is 1, is getting divided by cos squared of theta. Alright, so how can I rewrite sine squared theta over cos squared theta? 10. Sine over cos is 10. The sine squared over cos squared will be 10 squared theta. Alright, Cos squared divided by cos squared? 1, because they're the same thing, we cancel them. And how can I rewrite 1 over cos squared of theta? And the one with the tan is sexy. Okay, that's how you're going to learn those two. So,
No, we're just going to see a really hot person with a can and we're like, you remind me of that.
and the summaries in your notes. So, 5 identities. So we have tan of theta, which is sine of theta over cos of theta. Okay, and remember this also works if I do the following. So sine of theta, which is the opposite over the hypotenuse of your right angled triangle trig, and cos squared theta is the adjacent over hypotenuse. Now remember way back in chapter 1 or 2, when we're dividing by a fraction, we multiply by the reciprocal. So O over H, we are dividing by that fraction here. So when I divide by a fraction, I'll multiply by the reciprocal, A over H. Your H's cancel, which is O over A, which is tan of theta, with your right angle triangle. Alright, cool. So I've used it, we derived it from a unit circle. That's the other alternate way you can do it. Alright, number 2, we had cot theta, which is cos theta over sine of theta. Okay, so cot is the reciprocal of tan. Remember, take that third letter, it tells you what the reciprocal value is, and then we simply flip the fraction over. Okay, that is our second of our 5 identities. Alright, third one was sine squared of theta plus cos squared of theta, which is equal to 1. So no matter what the value for theta is, same value, sine squared of that angle plus cos squared of that angle will always result to 1. Okay? And like I said, we have done an example of this nature with sine squared of 45, I think it was, and cos squared of 45, and we showed that was 1. Coming on along those lines. Alright, number 4. So, you remember sine squared plus cos squared, which equals 1. If you don't remember the next two, we can derive it by dividing through by sine squared theta or dividing through by cos squared theta. Okay? So number 4, the one with the tan is sexy. And number 5, sorry, the one in the cot
It's also sexy.
I would like to think that it was cozy.
That's crazy.
I was just about to say Nathan in the cot is cozy.
Either way.
And then you're butting with your comment. Okay, so that's what you need to learn, those 5 identities. You mathematics student, okay? You don't necessarily need to remember how to derive them. You need to know those 5 identities. Extension 1, you also need to know those 5 identities, and I'll be paying particular attention on how they're being derived for your extension work when we do extension trig, okay? Right, so that's what we need to get out of it. A, example. So, what we've done here is not relating to what we did previously? Nope. Okay, so it's not relating to what we've done the last couple of days. So if you've been away, this is new again. So everyone's on the same page in terms of learning this for the first time. Okay, what we did the last couple of days was an extension on the quadrant and number plane where the ratios were positive or negative. Okay, right, example. Simplify. Right, so 1 take away sine squared theta. Simplify that. Oh, sorry, x. Doesn't matter. Theta. Oh, it had x in your notes, but it's just a variable. Right, so what can I simplify that expression to? Nope. So you've had 3 identities. Where in my 5 identity do I have 1 in sine squared theta? Number 3. Alright. So sine squared theta plus cos squared theta is equal to 1. That's your 3rd identity. Right, and now I need 1 take away sine squared theta. So if I subtract on both sides, I'm left with a cos squared theta is equal to 1 minus sine squared theta. Okay, so 1 take away sine squared theta is cos squared theta. Now, I have told you at the start of your course, and particularly on the start of your algebra, and also at the start of your equations topic, okay, this course is about 90% algebra and equations based. Okay, so yes, you need to know the skills from chapter 2 and 3 specifically, and you're going to see a lot of applications of that as we go through the course. Right, B. Sec squared theta take away tan squared theta. Alright, so which of my fourth one? Okay. 4th identity has both sec squared and tan squared. Alright, so you can either just write down the result. So I need sec squared take away, so I need to move that on the other side. And then when I do that, all I'm left with is 1 on the left-hand side. Alright, so the identity, if you haven't quite followed that process, 1 with the tan is sexy.
So is it acceptable to just put the 1, or do you have to go through the identity?
That's what I just said. You can just write the result if you can see it and move things quickly, and you can just write the result there. If you weren't able to follow that, you would need to do this, okay? So you take away tan squared theta from both sides, you're left with what we need. Okay? However, they won't always be this straightforward, okay? So you will need to eventually get to the point where you have to work things out, okay? Okay, so obviously it's a start to get you through and get you understanding of the applications of your identity. Right, C, tan of the angle capital A and close, yep, of the same angle. Right, what can I do? Good. How? Identity number 1 is tan squared theta. Sine squared. Sine over cos, which equals tan. Okay. So what I'm going to do is rewrite my tan of A as sine of A over cos of A times the second part of my expression there. All right. Cos of A cancels, and I'm left with sine of A. Alright, so if I pick an angle, I do tan of that angle times cos of that angle, and I do sine of that angle, I'm going to get the same value. Okay? Any question? Right, let's have a bit of a quick break on that. I want you to, without looking at your notes, what are these exact values? Without looking at your notes.
Okay.
And I want people who weren't here last week to have an opportunity to answer as well.
Okay, so we might as well play them.
Right, without looking at your notes.
Yeah, I'm still unsure about this thing.
This is all the halves and the...
Yeah, so
Right. Let's go a meter first, sine of 30.
No, I didn't.
I don't remember. I don't even remember that. Actually, is it?
It's Kyle.
I'm pretty sure there's like
One
a
half.
half in one for it.
That would be sine of 30.
That was literally my first.
And then sine of 45 is at 1 over root 2.
Yep, stop there. Stop there.
Shut. Let's do it 1 over.
Okay, so I have told you you need to learn this table off by heart, or you need to be able to derive them quickly. The other thing you can do is from sine of 30, you should be able to tell me the value of cos of 60. Right, back to your complementary. Sine of theta, which is cos of 90 take away theta. So sine of 30 equals cos of what? Cos of not 30.
60.
Well, sine of 30
30
equals cos of 90 take away 30. So cos of 60. So cos of 60 is going to be aha.
Oh!
See,
I
that's
thought
what
we
I
were
remembered.
talking about 60.
No, you were.
Now,
That's what I remembered.
what is cos of 45?
Would it be the same as Bob?
Yeah, it's gonna be-
Same as sine 45. Sine 45 equals cos of 90 take away 45, which is cos of 45. So that is 1 on root 2. So this is where we did the right angle triangles, and we did Pythagoras, we did, what else did we do? Pythagoras, oh, we split a equilateral triangle in half as well. Okay, that's where this comes from. Alright, sine of 60. So therefore, cos of 30 is, look at that, patterns in algebra. That's what you're identifying here. Yeah, you really should listen to your teachers all those years ago. Alright, tan of 30.
That's 1 over root
1 over root 3.
3. And the other ones are root 3 and root 1.
Alright, 45.
Root 3 and then 1.
That was
1, then root 3. Okay, so they get larger as they get larger for the value for tan. Alright, so 1 on root 3 is going to be the smallest number because it's a proper fraction, which is going to be less than 1. This is 1 square root of 3, which will be greater than 1. Okay, so that's the largest value over there. So you need to remember these. Alright, so I had students when I taught this 2 years ago, they actually drew it on their bathroom mirrors and they stuck it to the back of their toilet doors, okay, and they got really good at doing that. Okay, so I suggest you do the same. Okay, I also suggest to Kyle and put it on the bottom of his skateboard.
Yeah, Kyle.
I can't even write at the moment.
Yeah, you just look at it. Okay.
Alright, so whatever it's going to take for you to learn it, okay? let's simplify this one.
Tan plus cot.
Mhm. Right, so yes, it does equal tan plus cot, but when you get a question of this nature, what would be the first thing you would have done? Okay, put them on the common denominator. Alright, so the common denominator is sine theta cos theta, multiplying those two values together. Okay, and then you go through the process of multiplying across like that. So equals sine squared theta plus cos squared theta all over sine theta cos theta. Alright, what was sine squared plus cos squared? From your identity. Over sine theta cos theta. How can I rewrite that? Yes, which is what?
Reciprocal of
Cosec and cosec theta.
cosec theta plus.
Sec.
Now what is that one? How do we remember that one?
This, you're just deriving.
That's cosy and sexy in the same line from your previous.
Shut up,
Okay, so if I should go through and should work. Alright, let's just try Robin's suggestion. So, sine squared over cos squared plus cos squared over sine squared, which was tan theta plus cot theta. Okay, let's start it the way Robin suggested. I don't know, you probably would get your full marks, I guess. Not a lot we can do with tan and cot because they're not squared either, and we can't just square things. And the only thing we could do is rewrite it back in the question format. So you probably would get your full marks there.
So just like online instead of going through, but why are there different answers?
Hey,
Which
Well-
ones may end up being different answers?
cosec theta times sec of theta is also equal to tan of theta plus cot of theta.
So it's just an easier way.
Just different. I guess I would have to set both answers there, wouldn't I?
Whichever you understand.
We can't do any more with that. Now this was squared obviously, and this was tan squared plus cot squared. We could then go ahead and do more with it. But from there we can't actually do any more. The only thing we could do is go back to the original equation and then we'll take it through that work there. Alright. E. We are now proved. So these are your typically styles of examples, alright, for youth and identity. It's everyone's favourite. Prove.
So wasn't there a big flash when you recorded that?
Shouldn't. Alright, E. So tan of capital A, sine of capital A, which is, sorry, hang on. Yep. Tan A and then plus cos of capital A, which is equal to sec of capital A. Alright, prove. So you need to be able to manipulate one side or both sides of the equal sign in order to get an expression that is the same on both sides. Right, so I suggest you start with the side that has more information in it, alright? The left-hand side. To do a proof, I probably should make a page now. To do a proof, you need to set it out similar to what we're about to do. So, you need to start with either the left-hand side or right-hand side. Right, so what I'm going to do is I'm going to take tan of capital A times sine of capital A plus cos of capital A, and I'm going to manipulate it and do something in terms of the ratios I've got there and what I can set as equal, and get it to all equal sec of A. Alright? So, what can I do with the expression on the left-hand side? What could I substitute in? Yep, which one? Well, first, what can I replace with tan of capital A? Alright, so sine capital A over cos of capital A times sine of capital A. Just about. Cos of capital A. Alright, I'm not going to change that just yet. Right, so we've got sine squared of capital A over cos squared of A. Sorry, not cos squared. Just cos. Right, so sine A times sine A will become sine squared of A plus cos of A. What can I do next? Yep, common denominator, okay? Always be the guide that you're looking when you have multiple fractions, adding or subtracting, multiplying and dividing. Right, so the whole thing is going to be over cos of capital A. So we have sine squared of A. We don't have to change anything there. But because I've introduced the denominator over here of cos of A, I then need to multiply it by cos of A, cos to become cos squared of A. So if I were to simplify it, cos squared of A over cos of A, the square and the cos of A will cancel, and I'm left with just the cos of A on the bottom. Alright, so what is sine squared plus cos squared?
So why is the whole thing
So-
under the denominator of cos of A?
Because I had to introduce it for this fraction here.
Right. Why isn't it sine squared of A plus cos squared A equals sec A times cos of A?
Because I'm only just... Say it again, sorry.
Well, because you don't have to put the whole thing under the denominator, you just times it by cos A, and you sine squared A plus cos squared A.
Yeah, but then I also need to have it on the bottom. Because I need to introduce the denominator of here. Put them over the same denominator. Okay. Alright, x over y plus z. Essentially what that is at the moment. Right, ignoring that they're the same variable there. Okay, if I want to simplify that fraction, I would need to put everything over the common denominator. Yes? Alright. So, x on y. I don't have to change that because there's only one denominator. However, when I want to introduce the denominator onto the other side, so I can put it over the same denominator so I can add and subtract. Alright, I'll also have to do the same to the top. Alright, let's take it back another step. 2 over 3 plus 5. Okay, let's deal with numbers. You want to add those without your calculator. Alright, to be able to add those, you need to be able to put them over the common denominator. Okay? So, there's only one denominator, so that is going to be my common denominator. So when I add or subtract fractions, the bottom needs to be the same. Alright? That means I need to introduce that denominator 3 there. What will the numerator of that fraction be? Which came from 5 times 3.
You've got sin A over cos A plus cos A over 1, and it's sin squared A plus cos squared A over cos.
Yep, because I've done exactly the same process what I've done over there. Right, so let's go back one step. Right, so it equals sine squared of capital A over cos of capital A plus, now I need to introduce that denominator over this side as well. Okay, to be able to still make it equivalent, I need to have cos of A times cos of A. Yep. Then my denominators are the same. So cos of A times cos of A is cos squared of A. So I add the numerators and the denominator stays the same. Yep, which is what I have over here. Who's still lost? We're following? Right. So what sine squared plus cos squared? 1 over cos of A. What is 1 over cos of A? Sec. Which is what I've got on the right hand side. Okay, so what I've done is I've taken the expression on the left hand side of the equal sign and I'm going to manipulate it, substitute things in that are equal and get it to look like what I have on the right hand side. In other words, I'm manipulating this side to get it to equal sec of A. Alright, I do that through my substitution and rearranging of my trig identities, which is what we just covered, as well as obviously my algebra work. Okay, so you need to start at one side and then get it to equal the other side. So after you got it, you then need to say at the end equals right hand side. Right, I'm going to have to stop there, the bell's about to go. I will do that example again next lesson. And you guys need your books back, don't you?